In this section, we're going to be exploring conic sections. Conic sections are named as such because if you take something called a double cone, and this is a three-dimensional structure that's infinite and it keeps getting wider and wider in both directions, and upward and downward, and you take a cross section of a plane through this cone, depending on how you angle that plane, you'll get different cross sections, which are called the conic sections. They're sections of a cone. And so if you take it straight across, like this first example, and it's kind of, if you picture the cone having a base, it would be parallel to the base of the cone, and that would make a perfect circle shape if you could see it straight down from the top. So that is a circle. That is one conic section. Another conic section is if you take it to where this edge here is perpendicular with this edge of the plane. If you can picture that, then it comes straight through one of the cones and it makes an infinite structure that looks like this, and that's called a parabola. We've already done that in Algebra 2. And then we have if it comes through at a different angle, where you'll notice this parabola never hits this other edge. It will keep continuing to get wider and wider as the cone gets wider and wider, but it won't ever hit the other side. But if the plane comes through and hits both edges of the cone, but it doesn't go like the way the circle did, it doesn't go flat to where it's parallel to the base of the cone, then it will cause an oblong figure called an ellipse. So if you could, there is a difference between the circle. If you could look at it straight from the top, it would make a perfect circle, where on an ellipse, the plane's coming through at a slight angle, and that makes more of an oval figure, and it's called an ellipse. And then if you take the plane and drop it straight through to where it is now perpendicular with the base of the cone, then you have it to where it doesn't go right through the center of the cone, but it actually goes through a little off center of the middle of the cone, so it's over here. Then what will happen is it'll make this thing that is infinitely up and a little piece that's infinitely down, and it's kind of like a parabola, and it has a similar piece to its name. They both have bola in their name because they make kind of a bowl shape, and but a hyperbola will always have two pieces. It will have a piece going one direction and a piece going the other direction. It's got a very specific pattern to it. So the hyperbola is not the same as a parabola. It doesn't have the same features, but it has a similar look. Let's look at some properties of the different conic sections. Starting with parabola, which is something we've already done, usually we saw the parabola in this form, where it was y, and then the x was the thing being squared. And when that is the case, when there's a y that's not squared, but an x that is squared, then you can make it even in its most basic form, y equals x squared. That is an up or down parabola, depending on if a is positive or if a is negative. But one that we haven't dealt with yet is, what if it's x equals y squared? So in other words, the x is not squared and the y is squared. Then this is going to be a right parabola or a left parabola. And if a is positive, it's going to go to the right. If a is negative, it's going to go to the left. So that's what you're looking for in a parabola, is one of the variables is squared and one of the variables is not squared. Then for circle, you'll have both the x is squared and the y is squared, and you'll have a plus in between them. And that is very similar to circle and ellipse, are similar in their properties in that the x is squared and the y is squared, and it's a plus as well in the ellipse. The difference is there will be a number underneath, or sometimes that number will be in front, here and here. And if there's a coefficient in front of the x and a coefficient in front of the y, if they're the same coefficient in front of the x and the y, then that's going to be a circle. If there are different coefficients in front of the x squared and y squared, then you're going to have an ellipse, because that'll make it lopsided when there's different coefficients. So you're looking for the x being squared and the y being squared, and you're looking for a plus, but you want, if the coefficients in front of the x squared term or the y squared term are the same, it's a circle. If they're different, it's an ellipse. And remember, circle is this. It's exactly the same distance from a center no matter which direction you go, where an ellipse is more oblong, and it could be this kind of ellipse or this kind of ellipse, and it's got only 2 lines of symmetry, where a circle has an infinite number of lines of symmetry. Any line that you can draw through the center is a line of symmetry, so there's going to be an infinite number of those. Also, an axis of symmetry on the parabola is something that will be vertical on the y equals x squared type, and the axis of symmetry will be horizontal on the y squared type. Now, to see which direction that ellipse is going to go, if it's going to be bigger along the horizontal axis or if it's going to be bigger along the vertical axis, what you do is, it's always important to get a 1 over here. So whatever number might be on the other side of the equal sign, just divide it by itself and it will become 1, but then you divide everything by that number, and so you end up with denominators. And what you want to look for is, if the bigger number is under the x, it's going to look like this. So the bigger number is under the x squared term. And if it's under the y squared term, then it's going to go, so the bigger number is a, and if a is under the y, then you know it's going to be an up and down vertical ellipse. And lastly, for a hyperbola, the difference between an ellipse and a hyperbola, they look very similar, except for a hyperbola will have a minus sign in between the x squared and y squared instead of a plus sign. And then the a and the b can be the same or different. It doesn't matter. It will still be a hyperbola when there's a minus there. And then what you're looking for here is which one's first. So if the x squared is first in the subtraction, then that means the major axis of this thing will be along the direction of the x-axis. And if the y squared term is first, the major axis will be along the direction of the y-axis. And so this is when x squared is first, and this is when y squared is first. And this blue line isn't really part of the graph, it's just a line of symmetry basically, and it's called the major axis, but we'll learn more about that when we get into hyperbolas. But in other words, the curve is in a horizontal direction, going left and right when x squared is first, and it is in a vertical direction up and down when y squared is first. So it all depends on what's first, and that will determine where the 2 pieces of the hyperbola are going. Each of these pieces is called a branch, so there's 2 branches on a hyperbola all the time, unlike a parabola where there's only one of these 4 is going to be the actual parabola. It's not going to be all any two of those pieces. It's only going to be one of those for directions. So these equations that I have written here are the generic equations for any parabola, circle, ellipse, and hyperbola. And you'll notice all these H's and K's and A's and B's. Those are all things that are going to affect where this parabola or hyperbola or ellipse is going to land. In other words, these are shifts, and so you are going to shift left, right, up, and down according to the H's and K's, but we won't get into those until we actually get into each conic section individually, and then we'll talk about more of its features and more of the pieces that are involved with it. This was just an introduction to conic sections, and just so you know what they're all called and what some of their features are and what some of the things you look for when you look for the x and the y and which one's squared and which one's not squared, if they're connected with a plus, if they're connected with a minus, which one comes first, which one comes second. Those types of things will create to where you can just glance at an equation and know where it's going and kind of its general shape and direction. So that's an intro to conic sections.